and square every term. Okay, mathematically, that doesn't work. For the same reason that if you have x plus 3 squared, does that become x squared plus 9? No. So if I need to get rid of the square root, I can't just say, oh, I'm squaring each of those. What would I have to do if I squared right now? Yeah. Let's get rid of one at a time. So we're going to move one to the other side. Because we have two terms, and if we start squaring, we're going to have to FOIL. Now, when I do that, neatness is going to help you here. Just in the people that came in and asked me questions from the homework last night, most of the issues I saw were like dropping negatives, incorrectly multiplying things, just misreading numbers. So make sure that you can read your own handwriting as you go through here. When we square, we are squaring each side of the equation. On the left, if you square a square root, those just cancel and that gives us 2x plus 3. But on the right, because I have two terms added together, what do I have to do in order to square that? FOIL. So it's saying I have this parenthesis a second time. All right, let's try this. So 2 times 2 is 4. Do you need a pencil, Zach? Subtracting. Outside. Since this 2 is not under the radical, it just stays out in front. It's just a coefficient. So 2 radical x plus 2. Inside, 2 radical x plus 2. What happens if I take the square root of x plus 2 times the square root of x plus 2? It's the same thing as a square. If you square a square root, what happens? Cancels out, and it just gives me the x plus 2. All right, take a second. Are there any questions here? Did I get rid of all my radicals? No, but it's better. Let's simplify a little bit. 2x plus 3 equals, I'm going to add these radicals together, so you add the coefficients, and that's 4 radical x plus 2. We have plus an x plus 4 plus 2 would be 6. Now what do you think I should do? We still have a radical. You want to get rid of a radical, we have to get it side by itself. So let's move over the x and the 6. So if I subtract over my x, subtract over my 6, we get x minus 3 equals 4 radical x plus 2. All right. So I told you to get the radical by itself. Technically, it does still have a coefficient of 4. You could divide the 4 to the other side. We can also just square from here because it's all one term. There's no addition or subtraction. So if I want to get rid of this square root, we are going to square one final time. So on the left, this means I have x minus 3 twice. So it gives me x squared minus 3x, and minus 3x would be minus 6x plus 9. On the right, when I square, it means I have this whole thing twice. Okay, if you're multiplying that, you multiply in any order, what's 4 times 4? 16. What happens if you take the square root of x plus 2 times the square root of x plus 2? Cancels the radical. So we squared the 4, we dropped the radical. long process, but we are getting close now. Distribute the 16. Move everything to the left. So we get x squared minus 22x minus 23. What multiplies to negative 23 and adds to negative 22? If we set those equal to 0, we get 23 and negative 1. Do you guys have any questions for me? I know that was a long problem. That second radical really added a lot of work. Am I totally done right now? No. What do I need to do? Check our answers. When you check, always plug them back into the original problem. So if I put in 23, on a test or quiz, I really am not going to expect you to show me the work for how you checked, but I'm expecting you to do it. So if you leave an answer that wasn't correct, I will take off. But you don't have to write down how you check, because I know you might do it on your calculator. If you plug in 23, we get the square root of 49 minus the square root of 25 equals 2, and 7 minus 5 does equal 2. So 23 is good. Our other answer was negative 1. So if we get negative 1, negative 2 plus 3, so that's the square root of 1. Minus the square root of 1. 1 minus 1, is that 2? No. So negative 1 did not work. That means 23 is our only answer. We should probably try another one of those, shouldn't we? All right. What is my first step?
To add the x minus 1.
All right. We have to isolate one of them. This becomes 2 plus the square root of x minus 1. Now what? Square each side. So on the left, if it's just a single term, so the square and the square root drop. On the right, to square it, it means you have 2 of those parentheses because there's 2 terms, so we FOIL. So we get 4 plus 2 radical x minus 1 plus 2 radical x minus 1. And when you take the square root times itself, it just cancels. So plus x minus 1. Combine my terms. Radicals. Add the numbers in front. On our like terms, we have a 4 and a negative 1, so that's plus 3. Now what?
Get the radical 1.
So I'm going to subtract over the x and the 3. do we want to do from here? Square. Okay. So the left, we have two terms, so you have to think about it as FOILing. So you get 4x squared minus 4x and minus 4x and minus 8x plus 4. What do I get on the right? Right. 4 squared is 16, and the square root drops. And the reason I just square both pieces is that's one term. There's no addition or subtraction there. Distribute our 16. And now it's a quadratic. We need it equal to 0. So we subtract over the 16x, add over the 16. What do you notice about all of these? Okay, do you just want to divide both sides of our equation by 4 with some smaller numbers? What multiplies to 5 and adds to negative 6? You're thinking multiply 6 and add to 5. Alright. We set those to 0, we get x to be 1 or 5. But what do? Check. Just so you know, there is no guarantee that one answer works and one doesn't. It could be that neither one of them works, it could be that both of them do. Okay, so we just have to check every time. Always plug back into the original. So if you put in a 1, we get the square root of 4 minus the square root of 0. And 2 minus 0 does equal 2, so that one's good. What was my other one, 5? Okay, so I get the square root of 16 minus the square root of 4. And 4 minus 2 is also 2. So this time, both answers work. Okay, I know that process is long. Do we understand what's happening as we work through it? I want to look at one more type of problem. So before you get too excited about your homework, one final type of problem. Then you'll have some time to work on your homework. The last type is something that is like a quadratic, but not quite. Okay, so for instance, if you think about a quadratic, like 3x squared plus 5x plus 2 equals 0. What makes that a quadratic? Okay, what else? We have the x squared, the x, and the constant, right? When I say a quadratic form, that means it might be similar, but it's not really a true quadratic. So it might look like this. Or like this. Can you tell me why those two would be quadratic forms?
The exponents are not 2 and 1.
Okay, we don't have the typical quadratic of 2 and 1, but when I look, this is a 4 and 2. Half of 4 is 2. This one is 6. Half of 6 is 3. It could even be things like 3x to the 2/3 plus 5x to the 1/3. Because this exponent is 2/3 and half of 2/3 is 1/3, and then a constant. It could also be something that maybe it's a little uglier. Maybe I have like in parentheses Okay, this is like a quadratic because I have that entire parenthesis squared, the entire parenthesis to the first, and the constant. So these are things, they're not quadratics because our exponents are different, but they are like them, so we can use similar strategies. What we're going to talk about is substitution, okay, because some of these problems you could do other ways, but not all. Let's take a problem, and I'll show you what I mean. So let's say this is our problem. It is like a quadratic because I have an x plus 2 to the second, then I have a plain x plus 2, and then I have a constant. Now, on this particular one, could you multiply this whole thing out? Could you take x plus 2 and square it and combine like terms and factor? Yes. But if I made the exponent like a 2/3 and a 1/3, would you be able to multiply it out? No. So that's why I'm trying to show you a strategy that would always work on these types of problems. So if you got one like this on test and you chose to multiply it out, that is perfectly fine. But that won't always work. So what we're going to do is substitution. So we are going to pick a letter, I usually do U, and we're going to let it stand for that thing in parentheses. So U is going to be x plus 2. So every time I see an x plus 2, I'm writing a u in its place. Okay, so this becomes u squared plus 11u minus 12 equals 0. Did you guys do anything like this in algebra 2? Did you ever have substitution? Okay. All right. Is this a problem that you could factor and solve? Yeah. So what multiplies to negative 12 and adds to positive 11? 12 and negative 1. Okay, so if I set those equal to 0, I get that u can be negative 12 or positive 1. And that was pretty easy, right? But my original problem, u wasn't my variable. So now we have to go back. What does u stand for? X plus 2. So now I'm going to replace my u with x plus 2. So we just used the u for a little bit, so we have an easier looking problem to factor. But at the end, I have to find x, so I have to get rid of my u. Now, can you solve these and tell me what x is? Yeah, that's no big deal. We just subtract over our 2. So we get negative 14 and negative 1. What would always be a good idea on these problems? Check. Unlike the problems where we were adding squares or we had fractions, you shouldn't get answers that don't work. But you'll catch your mistakes if you check, okay? And I would just recommend grabbing a calculator and plugging it in and verifying. Make sure you include your parentheses where they're written in the problem. So like, for instance, if I put in my negative 14, I get negative 12 squared, so 144, plus negative 12 times 11, so negative 132. Minus 12, which is 0. I put in my negative 1. 1 squared is 1. 11 times 1 is 11. Minus 12, and that also equals 0. So you can see they both work. Is that one okay? What if, I have a lot of these. You guys will have to tell me how many we need. I want to do a few of them for sure. But then if we don't need all of them. Let's do, actually, can you guys do one like that one for me? See how far you can get before I do anything else. So what should my u be? I have to do a cursive S, otherwise they look like 5s in my problems. So then we have 2u squared minus 5u equals 3. Subtract over the 3. What do we do now? Slip and slide. What multiplies to -6 and adds to -5? And then remember, we started off multiplying the 2, so we divide the 2 back. So we get u to be 3 and -1/2. Is that okay? Are we done? No. We have to replace. U is equal to s plus 1. So I'm changing these u's back to s plus 1. So if we subtract our 1 over, we get s to be 2 and -3/2. Substitution is a tool to help you, but only use it if you need to. So basically, we use the substitution when we have a fairly complex looking thing and it's hard for us to factor. Okay, we can use it as a placeholder. Sometimes though, you might be able to take something that's like a quadratic and factor it without substitution. You may just be able to go through that slip and slide method with it, and that is perfectly okay. So an example of one that maybe you did substitution but maybe you wouldn't need to is this one. Alright, so we could do substitution here, but it's really not necessary because I don't have anything in my parentheses. This is a 4/3, half of that is 2/3, and a constant, so it's like a quadratic. We can just factor this easily. Y to the 2/3, how would you split that, or y to the 4/3, how would you split that one up? 2/3. Just divide it by 2, just like we factored problems that had an x to the 4th before, and we put an x squared in each. Now, what multiplies to 6 and adds to -5? Okay, so if you set those equal to 0, you get y to the 2/3 equals 2. And y to 2/3 equals 3. Okay, remember a 2/3 power. What does that mean in terms of radicals? It's the cube root of y squared. How do you get rid of a cube root? You would cube each side. You get y squared equals 8. How do you get rid of a square? And with it, you have to do, so we get plus and minus, 8 will break into 4 and 2, so 2 radical 2. So in this one, this is saying the cube root of y squared equals 3. Opposite of a cube root is a cube. Cube root, they cancel. So y squared equals 3 to the 3rd power is 27. Then what do we do? Square root plus and minus. So 27 break into 9 and 3, so 3 radical. Alright, so that one was uglier, but we could go through using our same factoring techniques. So, where we are at, I have finished this section now. Tomorrow, we are practicing all of this stuff again. So I'm not moving on yet. Tomorrow is just a review day over all of it. However, you do have homework. I gave you problems yesterday, so make sure you have those. Remember I did. You can add today's to it, but if you were gone, okay, that was yesterday's. Here's today's. Remember, what does EOO mean? Every other odd. If you get confused doing that, then just write them out. 69, 73, 77, 81, 85. So 8 more problems.